So hello everyone. So today we're going over 2.3, getting information from the graph of a function. First of all, we have by using the function, we're going to get all the information from the function. Like we have to know what is the domain, what is the range of the function by using the graph. Also, we're going to know how we can solving equation and inequality by using the graphs. Also, we're going over increasing and decreasing of the function. And in the end, we're going over the local maximum and the local minimum values of the function. So first of all, we have to know the value of a function like domain and the range. So the values of a function, domain, and range. So in the book, they start talk about this part of the section by giving examples. So the example is by using the graph, we have number 1, number 2, number 3, and 4, and 5 questions. So let me first graph the function. So suppose that this is my x-axis, and suppose this is my y-axis. Okay. Here we have 1, 2, so I'm going to make the distance correctly. Shorter than this. This is 1. Here is 2. This is the point 2 here. This is 2. This is 3. Here is 4. So 1, 2, 3, 4, and 5 is the 5. So I have a function. I'm going to grab the function in this here. This is 5, and this is also 6. We have 6. 6. Also, we have y values. Y values is same thing, but we're going to make the distance as like they work on 5. So this is here 5. Is 5. This is 10. This is 15. $20. And here is 25. 25, and 30. So the distance here 1 unit, here the distance is 5 units, 5, 10, 15, 20, 25, 30. Okay, so the graph of the function okay. You have 35. I missed the 35. Two is 3 is 30. Okay, like this. Yes. So the graph of the function look like this. Something like this. So the question is, are the questions we have some small things here. First question here, number 1. Find the value of f of 1. This is the function of function f of 3, comma, and f of 5. Number 2, question number 2, which is larger, f of 1 or f of 5. Question number 3, find the values of x for which f of x equal 25. And here the question number 4, find the value of x for which f of x is greater than 25. And the last question, find the net change from 1 to 3. Okay, find the value of f of 1, f of 3, f of 5. Question number 1. So the question actually for number 1, ask for the value of f of 1. This is mean we have to graph a line like this, and we have to find the length or the height from the x-axis until like this line at 1. We should to know to find the value, the distance or the height from the x-axis until where the line intersect the curve. So what's the value of f of 1? As I see here, the value of f of 1 is the height from this point, from the x-axis until where is the curve, until where is the line intersect the curve. So the line intersect the curve at this point. So the height is 25. So for f of 1, the value is 25. Now what is f of 3?
The value is
Is
35. Or
exactly. So
yeah.
f of 3 is, we should to graph a line like this. The height from the x-axis until where is
Oh yeah,
the,
sorry, I was looking at 2. It's
yeah,
30 then.
is 30 exactly. So the value is 30. So this time is, let me first of all remove, the value is 30. So here the f of 1, it shows the distance is 25. F of 3 is 30. What about f of 5? What is the height? Is 20 exactly. So as we see here at 5, the distance from the x-axis until where the line intersect the curve, at this point, it shows like this. So here is 20. Okay, for the second question. For the second question, which is larger, f1 or f5? So which is larger, f of 1 or f of 5? You go to the f of 1, you see the distance from the x-axis until the curve, until the line intersect the curve is 25. And for f of 5 is 20. So who's larger, 25 or 20? Natasha said f of 1. This is correct, 25. Layla, f of 1. This is correct because it's 25 and f of 5 is 20. The difference is 5. This is correct. So f of 1 is 25 and f of 5 is 20. So the larger is f of 5. So f of 5 is greater than f of 1. Why? Because f of 5 is 25 and f of 1 is 20. So 25 is greater than 20. Now for number 3. Question number 3 asks, find the values of x for which f of x equal 25. They ask which value of x from 1 to 6 such that the distance above the x-axis is 25. Yeah, I'm sorry, f of 5 here, f of 1 is greater than, I'm sorry, f of 1 is greater than f of 5. Make it smaller. Yes. Yes. F of 1 is 25 and f of 5 is 20. So f of 1 is greater than f of 5. That's correct. Now for question number 3, find the values of x for which f of x equal 25. So they ask which value of x from 1 to 6 such that the distance above the x-axis is 25 unit. So the 25 unit be like around here. This is the 25. So which value is like, you have to look to the red line such that which value of x such that this line intersect the curve. As we see here, the value that the line intersect the curve at this point and also at this point. So the value of x is, like Natasha said, 1 and 4. This is correct. Amr said 4, correct. But we have another point, Amr. And what is the second point? Is 1, correct. So as we see here, the horizontal line, the red one, intersect the curve at this point and also at this point. So it shows at this point, the x value is 1. And the second point, the x value is 4. So the both of the points are 1 and 4. So here 1 and I mean, like you should say x equal 1 and x equal 4, like this. Now question number 4. The question is, find the values of x for which f of x is greater than 25. Now the question is different. They ask for all values of x such that the length above the x-axis is 25 and is greater than 25, is not 25. And Natasha said 2 and 3. What about 2 and 5 and like 2 and 5? 2.5, I mean 2.5. What about this point? Natasha said 2 and 3. What about 2.5? Like this point is here. Yes. So what I can say here, again, the question asked about the height is 25. So the 25, the value is 25 is the horizontal line such that all the value is above 25 is starting from this point and ending at this point. So all points between this point and this point. What is all points? Yes, all points is bigger than 25. The distance from the x-axis until this line, the horizontal line, is 25. So they ask about the values of x such that is the
So
function greater than. Yes, go ahead.
would it be x equals 2 and x equals 3?
X equal 2 and x equal 3, this is correct. What about 2 and 2.5?
2.5 would work. Yeah,
This,
I
it's
think it
work,
would.
right?
Yes.
What about 2.6?
Oh, so it would be everything
2.7?
between 1.1 and 3, technically. I think
1.1 or 1 exactly?
1.5. Yeah.
What about if you use interval here?
Wait, give me a second. I can barely hear you. I have to turn off my headphones volume.
How can you use the interval here?
Hmm.
This is like open interval. Can you use the interval here?
I think you can.
How? Can you give me like open interval like this? Because the first point and the end point is not included. Which point is starting here?
Would it be 1.5 there?
1, exactly
Or
1.
yeah, 1. Yeah.
And what the point here end?
It would be, I guess 3. Yeah, 1, 3.
Yes, exactly 3. This is correct. Thank you. So at 1, we can start the interval, open interval like this, starting from 1, and all point after 1, like 1.1, 1.2, 1.3, all these points are included. 1.1, 1.2, 1.11, for example, 1.1, 2, 3, 4, like this. Like, I mean, all points starting from this point and ended, not 3, I mean, like it ended at this point. What is this point? Not 3 here, sorry. What's this point? 4, exactly. Sorry, it's not 3, it's 4. It started at 1 at this point, started at this point at 1 and ended at 4. All this point from here to here above this line are included. The point is starting at 1 and ended at 3, not 4. Ended at 4, I mean, not 3, 4. This point. So the open interval from 1 to 4 for number 3. Number 4, find the values of x for which we finished number 4. Number 5, find the net change from 1 to 3. Who will remind me what is the net change formula? What is the net change?
Is f of b minus f of a.
Exactly, f of b minus f of a. What is my b here? What's my b? What is the b value?
3.
Is it 1 or 3?
3.
Exactly. So the net change is equal f of b minus f of a. F of a. So my b here is a 3. So f of 3 minus f of 1. What is f of 3? What's the value for f of 3? We found it from the first question. What is f of 3?
30.
F of 3 is 30, exactly. And what is f of 1? Is 25. Correct, Natasha. So minus 25. Now, what is 30 minus 25? Is 5. So the net change is 5. The net change is 5. Any question for this example? Any question for this example? No questions? Okay, let's go to the domain and the range from the graph. So now from the graph, I can find the domain and range for any function. So now it will not be hard to find the domain and the range for any function. So now the domain and the range of the function. So the question is now, what is the domain? Anyone can remind me what is the mean of domain? What's the mean of domain?
The domain is all the x values.
X values, but any X values, I can here say.
Mhm.
Any X value, can I plug it? Or all possible X values?
All
That,
possible x values.
yes,
All
possible.
possible.
Exactly, that make the function defined, because I can't, for example, 1 over x, if I have function like this, I can't plug the 0 for this function. Why? Because 1 over 0 will be undefined. So here will be undefined function. That's why. So all possible values that make the function defined. And what is the range? Who will remind me what is the mean of range? Here is the input or the possible values can plug inside the function that make the function defined. But what is the range?
All possible y values.
Yes, all possible y values or possible output they give me from the function. So here I can say this is the input, domain input, set of input. Here is the output, the range, output. So I can, from the here output set. So now by using the graph, if I have a graph something like this, if I have my graph showing like this, And this is my graph here. The graph starts at this point. Here is so the graph starts at this point. This is suppose my x1. This is x1, and end at this point. And this is my x2. Also, at x1, the y value at x1 is here. This is y1, and suppose this is my y2. So from the graph, I can find the domain of and the range for any function. For any function, I can find the domain and the range. So the domain is all values, all x values that the function uses. So I mean for that, if we see here in this function, for example, and this is my function. Suppose this is my function f. This is my function f of x. So the function has a graph like this, starting at this point, ended at this point. So the domain will be all values, all x values that the function uses. So all values that the function uses is this, starting from x1 and it ended at x2. All these values in the x-axis are using. All these values are used. So this is my domain, starting at this point, ended at this point. So the domain is from x1 to x2. This is my domain of the function. Now the range is all y values are used. So starting from this point, because at x1 the value is y1, so starting at y1 and all y values here, all y values are used. So starting from y1 and all this y here are used. We use these values and we ended at this point. So this is my range. This is the range of the function f of x. It's clear? So from the function, from the graph, I can know what is the x values are used. This is me in the domain, and which y values are used. This is my range. Any question for this graph? Here I get a question. Can you repeat the net change? Okay. So the net change, the formula is f of b minus f of a. Ryan. Are you here, Ryan? The net change, the formula is f of b minus f of a. Okay. So my b here is 3. This is my 3. This is the value for b. This is b. And this is a. Just to plug it here. F of 3 minus f of 1. Now, f of 3 is given from the first part of the question. Here, look. We find it is 30. And f of 1 is 25. So 30 minus 25 is 5. This is the net change. You're welcome. Now we go back to the input and for the domain and the range. All x values are used in the function. Look, all x values, because the values here are used in the function, is the input. If you're starting at this point, x1, they give me y1, x2, y2, and all values between x1 and x2, we use it to define the function. So this is the domain. And the same things for the y. At x1, they give me y1. At x2, they give me y2. And all values here, after we plug it inside the function, they give me y values. So all these y values, the output, is called the range. So let me give you example for this to show you how we can find the domain and the range. So example, from the function, from the graph of the function below, find the domain and the range of the function. So I'm going to graph the function. From the graph of the function below, find the domain and the range of the function. So here is the graph of the function. We have half a circle like this. We have a half of circle like this. Yeah, I will go back for a second. Hold on 1 second. So this is the graph of the function. Can you go back? Here's Jennifer. Okay. The value here is -2. The value here is 2. And the value here is 2. The question is, find the domain and the range. What is the domain and the range of this function? This function, suppose this function is f of x. Now, what is the domain and what is the, what is the interval of the domain and what is the interval of the range of this function? You ask yourself which x value we use it to define this function from the graph.
How are you?
Can you repeat what you said? What x values we did use it to define this function?
Wouldn't we use the values of
If
-2
we
and
look
2?
into the x-axis, yes, but open, this is correct. But open interval or close interval? Like the -2 and 2 are included in the domain? This point and this point are included. The -2 here, the value, what is the minus here? If we start at this point, what's the value of -2? What is the y value of -2 here? Is 0, exactly. So we use the -2. So the -2 are included in the domain. What about the 2? What is the y value at 2? What's the y value at 2? 0, correct. So we use it. And all points between -2 are used. Why? Because look, at this value, the y is here. This is the y. This is the y. At this point, for example, if we keep all this value, we use it to graph the function. And at 0 exactly, what is the value at 0 exactly? What's the y value at 0? If x is 0, what's the y value? Is 2, correct, Natasha? Look, is the distance, the value at 0 is the distance. If we graph a line, like I said in the previous example, we graph a line and we see where is the line intersect the curve. So here is my line, for example. This is my line. And the line here intersect the curve. This is the curve at this point. This point is 2. So the value is 2. The same things here at any point. The distance is from here to here. So it has a value. The value is less than 2, like 1.8, for example. So be like around here, like around here, here. And this point is 1.8 approximately. And all this point, they use it. We use it to graph this function. So all these points, we use it. So this is the domain. All these points, we use it to graph the function. So the domain will be from -2 to 2. The domain here is the closed interval from -2, 2. The question is now, what is the range? What are the y values we use it as output for this function? What is the output? At -2, they give me 0. At -2, the y value is 0. What about the other values?
Wouldn't it be from 0 and 2?
Exactly, from 0 to 2. But what about the 0 and 2 included or not? Is it closed interval or open interval? We include the 0 and 2.
It does include it.
Yes, correct. We include it because at -2, when x equal -2 or x equal 2, the y value is 0. And all points between -2 and 2, they will use these values. Look at this point, for example, here. So intersect this curve at this point. So this is the y value. And the same things for another values. So this is mean the y we use it is starting from 0, goes up to 2. Because at x equals 0, they give me the value for is 2. So the range is from 0 to 2. Any question for this? Is it
Wait, so
easy to find the domain?
how do you know when to put closed interval or like
Yes.
not put it?
So you ask yourself at -2 or 2. For example, at 2. At 2, what is the y value? They
Is
give me a
it
y
2?
at
I mean
2
0.
is 0. So we use the 2. So at 2, we should be closed interval. At -2, what is the y value?
It's 0.
Is 0. So we close it. That's why. This is mean we use it. They give me a y value.
Oh, so we put the closed interval when we get a y value with it.
Yes,
And so if there was no y value, it would be open.
exactly.
Oh, okay.
Any question? When will be open? So the same, like the same graph. Suppose I have the same graph. So the question is, can you show example for when it would be open? Yes. So Like for example, something like this. And here we have here at, for example, -2, we don't have a y value. So it would be like something like this, open circle. Open circle here. And here we have -2, we have 2. So the question, the same things, find the domain and the range. What is the domain? What the x values we use it for this function? What x value we use it for this function?
-2 and 2.
Exactly, but is open or closed at -2?
Since it's open circle, -2 is gonna be open, and at 2, I think it's gonna be a bracket.
Exactly. So if we see here at -2 exactly, we don't have value. Why? Because the -2 is open circle. The open means is not included. So the value starting from the point is closing to -2 from this side, but at 2 is not included. All these values, x values are used. And also at 2 exactly, because the value at 2 is, what is the value at 2? What's the value at 2? Is 0 exactly. So its value at 2 is 0. So it will be like open circle at -2 and 0 at and 2. The 2 is include. Why? Because the value at 2 is 0. Now for the range, what is the range? What is the range? At 0 is included.
Yeah, 0 is included.
Yes, exactly, because the y value here, because the 2 has a y value is 0. So the 0 is included. And also 2 is included. Yes, because the value at 0, x equals 0, to give me 2. So the 2 is included too.
So -2 doesn't have a y value
-2 doesn't have a y value. So
because
it will
it's
be
not
like,
because it doesn't
yeah,
have a y value because it's open circle.
exactly. This is
Okay.
correct. Yes. There's 2. Okay, any question? Yes, Ryan. This is correct. So there will be open circle in the graph of show that we used the open. Yes. Now, so the domain and the range is done. Now let's go to the how we can solving equation and inequality graphically. Now let's go to how we can solving equation and inequality graphically. So now today we're going to solve equations by the graphs, and also the same things inequality by using the graphs. So the definition for this, or the idea for this, said the solutions, I mean, of the equation f of x equal g of x are the values of x where the graph of the function f and g intersect. So to find the solutions of the equation f of x equal the function, the second function g of x, we're looking where is the intersect between the both of the functions. This is the first point we have to know. The second point, so here start. Second point we have to know is the solutions, the same idea here. The solution of inequality, but not equation, inequality. F of x less than the second function, g of x, are the values of x where the graph of g, the graph of the function, where the graph of the function g is higher than the function, the graph of the function of the function f. So this is my two important idea how we can solving the equation and the inequality by the graph. So the first one, the solution of the function f equal g are the values of x where the graph, both of the graph are intersect. So we're looking for the intersect between the both of the graphs. For the second one, to solve the inequality, inequality means greater than, less than or equal, or greater than or equal. So suppose I have two functions. The first function is less than for the second function. The values of x where the graph of the function g, we look at the graph of the function g is higher or above of the second function, of the graph of the second function f. I'm going to show you this by graphing. So suppose my graph look like this. Here's my second graph. This is my first graph. So for the first one, my function f, suppose my first function is g. Here is my function g. This is my function g. No, it's not like this, like this. No. This first one, this is g of x. And the second one is the f of x, something like this. This is f of x. Now for the second function here, the graph f of x. And here is g of x. So for the first one, to looking for the solution of the function f equal g, the solutions for the function f of x equal the second function g of x, we're looking for the intersect between the both of the functions. So in the graph here, suppose my intersect so this is the intersect here. And the second one is the intersect here. The both of the function intersect at this point. So for the first function, intersect at the point A. This point is A. This point is B. Here is B. Again, the function g of x and the function f of x, both of them intersect at this point and at this point. So this is the solution when f of x equal g of x. This point and this point. This is the solution. The solution for the equation f of x equal the g of x are the values of x where the graph of the function f and g intersect. So the value of x is a, and the second value is b. So the solution for f of x equal the second function g of x here are the value a and the value b. Any question for the first one? How to find the solution for when the function f of x equal the function g of x? Is it clear for the first point? So again, if I bring you in the exam like two function, and the question is find f of x equal g of x, you have to looking for the intersect between the both of the functions. Now, for the second function, they ask the solution for the inequality. So here, again, suppose my point here this point is A, and this point is B. A, this is B. Now the question is the solution here, the solutions of the function f of x is less than g of x is the interval open parentheses a comma b. So all values such that the function f of x below the function g of x, the blue one, this is g of x, so all values such that the g of x is above of the function f of x is starting from this point, starting at this point, and ended at this point, because the function g of x, as we look into the graph, is above of the function f of x. All values starting from a, because the function here, look, is greater than the red one. The blue one is above of the red one, starting from this point a and ended at this point. All these values such that the g of x is above of the function f of x. So this is mean the solution of f of x, the red one, is less than of the function g of x is the interval, open interval, so starting from a and ended at this point is b. Now let me give you a graph example for this as a numbers. Any question before I move to the next slide?
Why is, for the first one, the solution not the interval, A, comma, B?
Here is not interval. Here, the solution for the first one, this one or this one, left or right?
The left.
Left. This is the left. So the solution for this one, f of x equal the g of x, the solution here always a point. Like for the solution always for equation is a point. So
Oh,
it would be like A and B only without interval. But the solution for any inequality always is interval. The solution for inequality less than or greater than always interval. But the solution for equation, this is equation f of x equal g of x. When you see equal, this is should be like the solution as a point, A and B. Why is A and why is B? Because look here, if you go back up, the solution of the equation f of x equal the function g of x are the values of x where the graph of the function f and the g intersect. So as we look in here, both of the red curve and the blue curve intersect at this point and also at this point. So the solution for this graph is A and B. But for the second one, if you look into the second star, the solution of the inequality f of x less than of g of x are the values of x where the graph of the function g, this one I mean, is higher than the graph of the function f, or is above the second function. So the solution of the g of x, the blue one, is greater than of the second one, the red one, will be in this interval. Look to the blue. The blue here, the blue curve, is above of the red curve. So this is mean the value or the solution will be starting from this point at the intersect A and ending at this point B. And should be open interval because here we don't have equal. F of x is less than or g of x is greater than f of x without the equal. So it will be like the open interval starting from this point, and all points here between A and B is making the function g of x greater than the function f of x or above. Look here above of the red one. But if we look into this interval, the blue one is behind or below the red one. Look at the blue. The blue curve is under the red one. This is mean is not my solution. My solution asks me when this curve g of x is above of the red one. G of x is greater than f of x.
okay. And so for the left one, could you put an interval, like closed interval, or just A and B?
It will be open interval because we don't have equal here. F of x
Oh
is less
no,
than.
not that
For,
one. But
for this
yeah,
one?
that one.
No, will
Yeah.
not have this always point. We don't have interval.
Oh, okay.
Always point.
Okay.
Yeah.
Okay, thank you.
No problem. Here, would there ever be a time where the f of x is above the g of x? Ever be a time? There be, ever be a time? So, can you explain your question exactly? What do you mean, Ryan? Can you explain? I'm going to give example to show how we can find this. By the example, I'll explain more. So the example is solve the given equation. So the first one is number one, find x squared. Here one, x squared equal the function x plus 2. Second question is when f of x squared is less than here, x squared less than x plus 2. And the third one is x squared greater than the function x plus 2. So this is x squared here. Here x squared. Here x squared. Here x squared. It like would the red curve ever be greater? Yeah, it will be greater forever here. So this is not my solution. Will be greater from comparing to the blue one is greater than the blue one forever here in this side and also on this side. Also on this side will be greater. But the g of x will be greater than the f of x only inside this interval. Only from here at this point and ending at this point. Only at this interval. Start from this point A and ending at this point B. And about this, the red one will be like greater than the blue one. I mean the function f of x will be greater than g of x forever. Would the formula change if the red curve is greater? The formula, if the formula here, f of x is greater than f of x is greater than g of x, the solution will not be like this. The solution will be anything smaller than a and anything greater than b. I will explain this by the example. Look to the example below here. To this example. I explain this by this example. Okay, Ryan? So for the first one, okay. So who will do, who know the graph of the first function, x squared? What's the graph of the function x squared? What's the graph of the function x squared? It's a parabola, right? It looks like this. Like a cup. We learned how to graph it last time by using a table. So you should to know how to graph the function x squared. Why? Because we learned how to graph this function last time by using the tables and plotting points. Now, who know the graph? This is the function x squared. Who know how to graph the function x plus 2? What is the function x plus 2? What's the function x plus 2? It's a line,
has a
right?
y-intercept of 2.
Exactly. Yeah. It's a line. We have a reciprocal at y, reciprocal is 2. So x plus 2, it's a line. And we have a y-intercept. What's the y-intercept for this line?
2.
What's the y? It's exactly 2. This is my b. So at 2, this is 1, this is 2. At 2, exactly here, we have the y-intercept. So what is the x-intercept for this one? If my function y equal x plus 2. So my y-intercept is 2. What is the x-intercept?
-2.
You set this 0, exactly -2, x plus 2. Now you solve it, -2 from both sides. So I get x equal -2, exactly. So at -2, it's my y-intercept. So -2. At -2, it's my y-intercept. Now to graph this function, just look like this. Line that passing the 2, the -2, and 2. So the y-intercept is 2. This is 2 here. And the x-intercept is -2, like this. And this is -1. So the curve and the line intercept. So the curve and the line intersect at which point? If we're looking here, this point here is -1. This point is -1, and also this point here is 2. So for the first one, x squared equal x plus 2, what is the solution? What's the solution for the first one?
-1, 1,
-1 and what? -1 is correct. And what is the second point?
and 2.
And 2, exactly. So we're looking for the intersect between the both of the curve. So the curve, the first curve is x squared. So this is the curve x squared, the parabola, like a cup. And the second curve is the line, the red line. So you're looking for the first one, x squared equal x plus 2. You're looking for the intersect between the both curves. The intersect at this point. This point is the intersect, and this point. So the x value at this point is -1, and the x value at this point is 2. So the solution here for number 1 is x equal -1 and x equal 2. For question number 2, they ask when x squared is less than x plus 2, or in a different way, when the x plus 2 is above of the function x squared. When this value, when the function, the red line, will be above of the of the parabola of the cup. Because here we have
1
inequality,
to
so
2.
the solution will be, yes, 1 to 2, exactly. Because here we have inequality, you have to use interval to the solution. So the question is from 1 to 2 or from -1 here? Can you repeat what you said?
Yeah, -1 to 2.
Exactly, from -1 to 2, and should be like open interval like this, -1 to 2. This is the solution because the red one will be above of the black curve. The red one will be above of the parabola, the cup, inside this interval from -1 to 2. Look, the red line will be above of the black line curve at this point, starting from this point. Look. Then the black parabola will be above of the red line. And here the same things will be above of the red line. For the third one, who will do the third one? Correct, Rashid. -1 to 2. This is correct. Or you can write it as x between -1 to 2. This is correct. Like as we learned in the interval. Number 3, when the x squared will be greater than x plus 2. Or in different word, when the curve x squared will be above of the curve x plus 2. So x squared will be above of x plus 2 at which interval? We have two intervals. The black one here, the parabola, will be above of the red one before this point, before the -2. Like all values here will be a solution for this, and also all the solution here above of the 2, after the 2, will be a solution. Why? Because the parabola, if we're looking here to the curve, will be above of the red one. Like Rashid said, x less than -2, -1, this is correct, and all values x above of greater than 2, this is correct. So again, the question here, number 3, when the parabola x squared will be above, greater than means above of x plus 2, will be above of the second curve, all points is less than -1. Look, the parabola, the black one, is above of the red one, everything less than minus 1, I mean. And the same thing is in this side. All values greater than 2 will be the parabola, the black curve above of the red curve. So the solution is from minus infinity to minus 1 and from 2 to infinity. Or in different way, like, or we can say x less than minus 1 and x greater than 2. All values greater than 2, and here all values less than minus 1 would be the solution. Any question? Any question for this one? Okay, so now let's go to the increasing and decreasing function. So increasing and decreasing function. So we have definition for increasing and decreasing. So the definition is definition. So f, we said the function f is increasing on an interval I if the f of x1, if f of x1 is less than f of x2. Whenever x1 less than x2 on the interval I. I'm going to explain what I said here. Also, we have to know the decreasing function is decreasing on an interval I if f of x1 is greater than here, whenever x1 is less than x2. Okay. So f is increasing on an interval I if f of x1 less than whenever x1 is less than x2 in the interval I. The same things for the second function. I'm going to graph two functions to explain more how we can see the increasing and decreasing function. So for the first one, suppose my function looks like this. Is it closed or open? What do you mean closed or open? The interval is open. Open interval. Should be open interval. For the second function, suppose my graph for the first one look like this. Something like this. This is the increasing function. And for the second function, something like this. This is decreasing function. So how we know the first one is increasing and how we know the second one is decreasing? Okay, so by using the definition, if I have x1, so suppose my function starting at this point, this is x1. I mean like starting at this point, but this is not my x1. Suppose I want to take a point in the mid. Suppose here, my x1. This is my x1. And also it has a y values. Here's the y value, or f of x1. This is f of x1. Suppose this is my x2. And this is my y value. This is f of x2. Same things here. Suppose this is my x1 here. And here is my f of x1. And this is my x2. And this is f of x2. Again, this is my function f of x. And this function is f of x. So for the first one, we said this function is increasing because if we take 2 points, x1 and x2, such that the value of x2 is greater than x1. As we're going here, x2, the value for x2 is greater than x1, and in the same times, the f of x2 is here is greater than f of x1. So this function is increasing. Again, the function is increasing if x2 is greater than x1, and at the same times, f of x2 is greater than f of x1. So this function here is increasing. Why? You have to apply the definition for this function. x2 is greater than x1, and in the same time, f of x2 is greater than f of x1. But for the second function, is decreasing. Why? Because x2 is greater than x1, but f of x2 is less than of f of x1. The y value here, or f of x1, is less than the value here for f of x2. Again, x2 is greater than x1, but f of x2 less than of f of x1. This interval in the I, this is I. If you want to see why the function here increasing by your eyes, starting from the left to the right, like this, starting from the left to the right, and check how is the function look like. The function here look like going up as increasing, going up to the mountain. So this function is increasing. But for the second function, here again, starting from the left and see the function. The function looking is increasing. But for the second function, if you're starting from the left, always start from the left to the right, you will see the function is going down. So this is mean decreasing. So the function here decreasing, the function here is increasing. Make sense? If you don't want to use the definition, if I ask you the question in the example, this is increasing or decreasing, starting from the left the points from the left to the right and check how does the function look like by your eyes. It's increasing, going up, like going to the mountain, to the top. But for the second function, start from the left to the right, you will see the function goes down, so decreasing. And if you want to use the definition, just applying the definition, x2 is greater than x1, but f of x2 also, if f of x2 is greater than f of x1, this means the function is increasing. But for the second one, x2 is greater than x1, but the problem here, f of x2 is less than f of x1. So this means the function is decreasing. I'm going to give you example for this. To tell me at which interval is increasing and which interval is decreasing. So the example like this. Find the in which f is increasing and in which f is decreasing from the graph below. The question is find the interval for increasing and decreasing from the graph. So suppose my graph look like this. Here's my x-axis. This is my y-axis. The graph of this is looking like this. This is A. Again, this is A. A, B, C, D, E. The question is at which interval the function is increasing and at which interval the function is decreasing. And this is the function f of x. Who will do this one?
I would say it
Yes,
f
go
is
ahead.
increasing in the interval from A to B, and it would be decreasing
Okay.
in the interval from B to C.
From
And then-
B, from
Yeah.
B to C is increasing,
Decreasing.
decreasing. And what what is increasing again?
C to D.
C to D, exactly.
Yeah,
And what about D to E?
it's decreasing.
Decreasing, correct. So as I said before, you have to look into the graph like this, and you have to check which interval is increasing. So the increasing, it shows here, if I start from the left side to the right side, starting from this point, it shows the function is increasing at this interval from A to B, and also increasing starting from here to this point. So the function is increasing also at this point. But if we look into the decreasing, it shows from this point, goes down, and from this point goes down like this until this point. So the increasing interval, you can see here, the increasing interval or the open from A to this point B, and also from C to D, C comma D, and decreasing is from B to C and from D to E. Is it clear? Perfect. So the increasing from A to B, because going up to the mountain, going from the top of the mountain to down is decreasing from B to C. Going up again from C to D, this is increasing, and this is decreasing again from D to E. Can you go back? Yes, here. Jennifer. Now, this top of the mountain is called the local maximum point. This point, changing from increasing to decreasing, called local maximum. From decreasing to increasing, called local minimum. This is called local minimum point. This point from increasing to decreasing called local maximum point. So I'm going to define the local maximum and local minimum points values. So local maximum and minimum values of a function. The local maximum and local minimum values. When the function from the graph changing from increasing to decreasing, called local from increasing. When the function, if we're looking here, changing from increasing to decreasing, this point here called local maximum. When the function changing from decreasing to increasing, this point here called local minimum. Again, when the function changing from increasing to decreasing, this point again, local maximum. So I'm going to give example here, or I'm going to show you in the graph, the local maximum and local minimum, and we're going to finish this lecture for today. So suppose my function look like this. The function like this, like going up like this, going down. Now the function, like I said before, changing from increasing to decreasing, here going up to this point, then going down, stop at this point, then going up again at this point, then going down again and up. So this point here, this point, and this point called local maximum point. Local maximum points. And this point down, and this point called local minimum point. So suppose this point here suppose this point here is A, this point is B, this point here is C, and this point is D. So you can see here the function f of x has local maximum point at x equal A and at x equal C, and also and the function again f of x has local minimum points at x equal B and at x equal D. This is very important. You should to know it. So at x equal A and at x equal C, we have two local maximum and the same things for the local minimum. Any question for this graph? Any question for the local maximum points and local minimum points? Okay, we can stop up to here today. And good luck in the exam Wednesday. See you Wednesday.
Are any of the topics on this